In our previous topic, we have discussed what are calomel electrodes, what are reference electrodes, and seen the construction working of calomel electrode and applications of calomel electrode. So calomel electrode is also a type of reference electrode where calomel electrode is used to measure the electropotential of unknown electrode. It is also used to determine the endpoint of all redox reactions. It is also used to determine the as reference electron determination of pH. So now we have a separate class of reference electrodes. Those are called as ion selective electrodes. Today let us discuss what are ion selective electrodes and let us see what is glass electrode, construction and working of glass electrodes, advantages and applications of glass electrodes in today's discussion. So let us discuss one by one. Ion selective electrodes. So ion selective electrodes are type of reference electrodes which responds to concentration of only one specific type of ions, even when it is dipped in a solution containing mixture of ions. For example, this solution contains n number of ions. It may contain Na+, it may contain H+ ions, it may contain lithium ions, it may contain Cl- ions, etc. So we are supposed to determine the concentration of Cl- ion itself. So we are going to design an electrode to determine the concentration of Cl- ion itself. So if this is the electrode, determines the concentration of Cl- ion when we dip in a solution which contains sodium, chlorine, hydrogen, potassium, etc. The potential of this electrode corresponds to the concentration of chloride ions itself. So such type of ion electrode is called as ion selective electrode. So ion selective electrodes are defined as or reference electrodes which responds, whereas the electropotential corresponds to the concentration of only specific type of ions even when it is dipped in a solution containing mixture of ions. For example, glass electrode responds to the concentration of only H+ ions, therefore it is used to determine the pH. Similarly, for lithium, we have a separate electrode. For determination of fluoride, we have different electrode. So this ion selective electrodes have contributed much. So now you know, so when we install a RO filter in our water, they come to home and determine the pH because its contribution is given by pH electrode. Determine the concentration of fluoride. So as soon as I dip the electrode into it, so glass electrode will tell you pH, the fluoride electrode will give you the fluoride concentration, and we have different electrode determine the total hardness also. So earlier, if you want to determine the total hardness, pH and fluoride content, you suppose send the water sample to the laboratory, and by the time we get it is to be 15 days. But now it is very simple. So in this spot, on this spot, we will come to know the pH, fluoride and total hardness of the water. So we have different types of membranes available in the ion selective electrodes. So what are those? Those are solid state membrane ion selective electrode, liquid membrane ion selective electrode, heterogeneous membrane ion selective electrode, and glass membrane ion selective electrode. So today we will discuss only the glass membrane ion selective electrode. So glass electrode. So glass electrode depends. So our glass electrode consists of. So glass electrode consists of a round bottom. So glass electrode consists of what? It consists it is a glass electrode, example of ion selective electrode. So glass electrode consists, or it is made up of, glass electrode is made up of a special type of glass. This is special type of glass with low melting point and high conductivity. So this is the glass bulb. This glass bulb is made up of low melting point and high conductivity. So here the glass bulbs contains a solution, this solution of known pH and concentration. So usually your solution is HCl, and it is the concentration of this is 1 molar concentration. So it also contains an internal reference electrode, and commonly used electrode as silver chloride electrode. Okay, so I repeat. So the glass electrode consists of, or it is made up of a special type of electrode, special type of glass bulb with low melting point and high conductivity. So inside that we are going to take a H+ ion of known concentration, usually HCl of 1 molar concentration. It also contains contains internal reference electrode, that is silver chloride electrode. This entire glass bulb will be kept in a solution of H plus ion of unknown concentration. So this gives us the glass electrode. So next, so what happens when the glass electrode is, the glass electrode can also be represented. The glass electrode is represented as, so AgAgCl, so this is the internal reference electrode and it is dipped in 0.1 molar HCl and it is the glass membrane. So the glass electrode here, which we have diagrammatically written, can also be represented by the representation given over here. So the glass, at the glass electrode, what happens? Ion exchange reaction occurs across the membrane. So the H plus ions present inside the bulb will get exchanged to the H plus ion present outside the bulb. The H plus ions present inside the bulb, you know the concentration, it is 1 molar concentration. The H plus ion present outside the bulb of unknown concentration. Therefore, there will be exchange of H plus ions through the glass membrane. So why it exchanges? Because it is the glass is made up of special glass bulb with high conductivity. Since the conductivity is high, so across the membrane there will be a exchange of H plus ions. So until when it exchanges, until the concentration of H plus ions inside the bulb and the concentration of H plus ions outside the bulb are equal, it gets exchanged. So this is shown. So the ion exchange reaction is shown here. So the H plus ions inside the bulb will get exchanged with the glass. So the glass is represented by Na plus and Gl minus. It get exchanged with that and you get Na plus and H plus Gl minus. This is the reversible reaction. So the electrode potential of the glass is given by Eg equals Eg naught minus 0.0591 pH. So once again, this is also derived by the Nernst equation. So since we don't have Nernst equation, so the electrode, we don't have the derivation of this, we're going to just give the electrode potential. The electrode potential of glass electrode is determined by Eg equals Eg naught minus 0.0591 pH, where Eg naught is the constant. It is given as, it is the sum of EAgAgCl, that is internal reference electrode, and asymmetric potential, and K. You might ask, what is asymmetric potential? So asymmetric potential is nothing but, so as I told you, since the H plus ions inside the bulb and outside the bulb are different, there will be some ion exchange reaction occurs. So this ion exchange reaction occurs until the H plus ion inside the bulb and outside the bulb are different. Once the concentration of H plus ion inside the bulb and outside the bulb are equal, this ion exchange reaction will not occur. It should be 0. But in practical, even when the concentration of H plus ions inside the bulb and outside the bulb are equal, we can observe some potential across the boundary, and that potential is called as asymmetric potential. So what is asymmetric potential? Even when the concentration of H plus ions inside the bulb and outside the bulb are equal, we observe some potential across the boundary, and that potential is called as asymmetric potential. So that is also considered over here. So Eg naught is given as, Eg naught is sum of silver electropotential, internal reference potential, asymmetric potential, and the constant K. So this Eg naught is constant. Okay, so pH we know. When we substitute here, we get the electropotential of the glass. When we substitute the pH value of the solution, that is HCl, and E naught G is constant. When we substitute here, we can easily determine the electropotential of the glass electrode. Okay, so let us see the advantages of glass electrode. It can be used in presence of oxidizing agent, it can be used in presence of reducing agent, and also in presence of complexing agent. Right. So these are some of the advantages of glass electrode. So if there are advantages, obviously there will be disadvantages also. So what are the disadvantages? So it is very delicate. The glass bulb, it is, even though it is made up of a special type of glass with low melting point and high conductivity, it is very delicate. It cannot be used in the dehydrating agents such as acids, alcohol, etc. And this cannot be used. The glass electrode cannot be used pH above 12. So it can be used above pH 12, but it gives some errors. So accurate results can be obtained only for pH below 12. So what happens is, the because of hydroxyl ions. Okay, so in order to get equilibrium, it takes some time, because the glass electrode also offers some resistance. So these are some disadvantages of the glass electrode. So now let us see the applications or uses of glass electrode. So these glass electrodes are used in pH measurement. So let us see how to determine the pH using glass electrode in our next discussion. It is used to determine the pH of the food, used to determine or analyze the cosmetics pH, food pH, environmental regulation, acidity and basicity of the soil. So especially the soil, in order to get a good crop, right, the pH value of the soil is also very important. So when such cases, we're going to use this glass electrode. So glass electrode, it is mainly used to determine the pH. So how to determine the pH, we'll discuss in our next discussion. Thank you.